All right, let's talk about a story that sounds like it was ripped straight from a sci-fi epic, but I promise you, it's happening right now out in the deep dark void. We're talking about cosmic monsters, violently ejected from their homes, and now they're wandering. This is the incredible story of rogue black holes. And let's meet our main character. I want you to picture something, an object with the mass of 20 million suns. It's totally invisible, and it's moving so fast it could travel from the Earth to the Moon in just 14 minutes. This isn't some theoretical idea. Astronomers have actually found it. And the crazy part? It's just the first one we've confirmed, a sign of a whole hidden population of cosmic wanderers. Now, to really grasp why this discovery is such a bombshell, we first need to talk about what we thought we knew. You see, for decades, our whole picture of the universe's biggest black holes was one of, well, stability. Okay, so a supermassive black hole, or SMBH, think of it as the cosmic anchor of a galaxy. Right in the heart of our own Milky Way, we've got Sagittarius A star. These things are so unbelievably massive that their gravity basically dictates the entire structure of the galaxy around them. The assumption was pretty simple. They sit in the middle and they stay put. And this was, for all intents and purposes, the rulebook. The galactic center was the permanent, unchangeable address for any supermassive black hole. They were these calm, gravitational linchpins that the whole chaotic dance of the galaxy revolved around. But this simple, elegant picture, it was about to get completely shattered. Because here's the thing. The universe is anything but static. It's a violent, dynamic place. Galaxies are constantly bumping into each other, merging in these spectacular cosmic collisions that play out over millions of years. And when two galaxies smash together, their central supermassive black holes start this slow cosmic dance, spiraling closer and closer to each other. And that is where things get really, really interesting. Which brings us to our next chapter, the Great Cosmic Escape. Because it turns out that under just the right chaotic conditions, a supermassive black hole can get violently kicked right out of its own home galaxy. And that's the big question, right? What kind of force could possibly be powerful enough to unhitch an object millions of times heavier than our sun and just fling it into the empty void? The answer, it turns out, lies in some of the most extreme physics the universe has to offer. So, how does a black hole pull off this escape act? Well, there are two main ways. On the left, you've got something called gravitational wave recoil. When two black holes merge, they send out these powerful ripples in space-time. Now, if that merger isn't perfectly symmetrical, say one is heavier or they're spinning at weird angles, the waves blast out more powerfully in one direction. And for every action, there's an equal and opposite reaction. The new, bigger black hole gets a massive kick in the other direction, sometimes hard enough to escape the galaxy for good. Then on the right, you have the three-body slingshot. This is just pure cosmic billiards. Imagine two black holes already orbiting each other, and then a third from another galaxy merger stumbles into the party. The whole system goes haywire, and more often than not, the lightest of the three gets shot out at an absolutely incredible speed. You know, for years, this was all just theory. It was an idea on a blackboard. As astronomer Peter Van Dockum, who actually led this discovery team, said, the forces you're talking about are just enormous. It was a wild prediction that was just waiting for someone to find the proof. And in 2023, that proof finally arrived. And wow, was it spectacular. And this is where the story gets really good. Because it wasn't the black hole they saw first. Nope. It was the unbelievable trail it left in its wake. Imagine you're an astronomer sifting through old Hubble images, and you spot this. A perfectly straight, impossibly thin line of bright blue stars just stretching away from a distant galaxy. It didn't look like anything anyone had ever seen before. It wasn't a jet, those fan out. This was a wake, like a boat carving through water. And when they started analyzing it, the numbers were just staggering. The object at the tip of the spear has a mass of 20 million suns. It's traveling at over 2 million miles per hour. But look at that trail. It's 200,000 light years long. That is twice the diameter of our entire Milky Way galaxy. Just to put that speed into perspective, it would take this rogue black hole a mere 14 minutes to get from here to the moon. It's moving at 3,000 times the speed of sound. But here is the most mind-bending part of this whole discovery. You would think, right, that a runaway black hole would just be a path of pure destruction, a cosmic wrecking ball. And yet, that brilliant trail it's leaving behind, It's not a scar. It's a stellar nursery. So how does that even happen? Well, first, as the black hole plows through the thin gas that surrounds its old galaxy, it creates this powerful shockwave in front of it, just like a supersonic jet. That shockwave slams into the gas and compresses it like crazy. That sudden compression lets the gas cool down really, really fast. And once you've got a pocket of dense, cool gas, well, gravity takes over. The gas starts collapsing in on itself, and boom, you get a whole chain of brand new, hot blue stars. We are literally watching a completely new way for stars to form, happening way out in the middle of nowhere.
Now, it's really easy to think of this as some strange, exotic event happening billions of light years away. But the very same models that predict that runaway black hole also predict that we should have a few much, much closer to home.
That's right. The same violent cosmic dynamics that ejected that monster are a totally natural part of how galaxies form everywhere, and that includes the history of our own Milky Way. Which means there are probably invisible wanderers hiding in our own cosmic backyard right now. The simulations give us a fascinating and maybe slightly unnerving prediction. A galaxy the size of the Milky Way should be hosting around 10 of these wandering black holes. Most of them, maybe 7 or so, are probably out in the huge, sparse halo that surrounds our galaxy, remnants of smaller galaxies we've eaten in the past. But about 3 of them, they could be wandering right here in the galactic disk with all the rest of us, leftovers from major mergers deep in our galaxy's past. So this, of course, raises the big question. If they're out there, how in the world do we find them? I mean, by definition, they're black. They don't give off any light. So astronomers have to get really, really clever. And this is how the hunt is on. There are 3 main methods. First, there's microlensing. As a rogue black hole happens to pass in front of a distant star, its gravity bends the starlight, which makes the star briefly look brighter and even shift its position in a very specific telltale way. Second, they're looking for something called tidal disruption events. That's when a star gets a little too close and gets violently shredded. If you see one of those flares happen far away from the center of any galaxy, that's a dead giveaway for a wanderer. And finally, we're looking to the future with missions like LISA that will be able to actually hear the gravitational waves from the very mergers that create these runaways, letting us trace them right back to their origin story. So, here's the bottom line. The discovery of a star-forming runaway black hole has completely upended our understanding. It shows us a universe that's so much more dynamic, more violent, and weirdly enough, more creative than we ever imagined. It turns a static anchor into a wandering creator. And it just leaves us with this one final, huge question to think about. What other cosmic rules that we take for granted are just out there, waiting for us to see them being broken?